Here we have another radical equation. Our first step is always to make sure that the radical is alone on one side, which it is. There's nothing over here that's not under the radical. The x over here doesn't have a radical. It's already been moved over. So then we want to remove the square root, so we do that by squaring both sides of the equation. And that gives me 9x minus 20 equals x squared. So this one's a little bit more work than my previous examples because I notice it's quadratic. I have an x squared, I have an x, and I have a constant. So I'm going to move everything over here to this side of the equation because I know when you're solving quadratics, it has to be equal to 0 before I start, and then I can solve by either factoring or using the quadratic formula. So this is a positive 9x, so I'm going to subtract 9x from both sides to move it over. I have a minus 20, so I'm going to add 20 to both sides to move that over. When I write it down, I'm going to write it in the order I'm used to seeing quadratics. I'm going to go ahead and put the x squared first, and then minus 9x, and then plus 20. So it's now set equal to 0. It's quadratic, so I'm going to solve by factoring if it will factor, so I'm going to try that first. I'm write down my two parentheses because there was not a number in front of the x squared. I know I'm going to have an x on the front of each one to give me that x squared if I were to multiply through. And then I need factors of 20 that add to equal negative 9. So whatever it takes to get through all of the factors, 4 and 5, if they're both negative, negative 4 plus negative 5 is negative 9. And negative 4 times negative 5 is still a positive 20. So these two work, and so I know my factors are x minus 4 and x minus 5. After factoring, then we set each factor equal to 0 and solve, because we know in order for that to equal 0, that product, one of these has to be 0, or both. So now I solve each equation. If I add 4, I get x equals 4 and x equals 5. As always with radicals, I have to check both of those answers to make sure they actually work in the original equation. So let's start by checking 4. So again, you write down the original equation but replace the x's with 4. So I had 9 times x, so 9 times 4, because that's the solution I'm checking, minus 20. We're seeing the square root of that is equal to x. My x, again, was 4. That's the one I'm checking. 9 times 4 is 36. 36 minus 20 is 16. And the square root of 16 is 4. So yes, this first solution does work out. Now let's check 5. So we're going to do the same thing, original equation, but replace the x's with a 5. So 9 times x, put my 5 there, minus 20. Is that equal to x? Again, we're checking to see if 5 works there. 9 times 5 is 45. 45 minus 20 is 25. So the question is the square root of 25 equal to 5? And it is. So I have two correct solutions to this problem, x equals 4 and x equals 5.